So today we're going to be learning stuff with direct variation, constant variation, and types of proportionalities we're going to look at. So here, to find the constant variation is the same thing as the slope. Okay? What it's talking about is the constant variation is what is happening to our graph. Okay? So it's like the slope of what's happening to our graph. Okay? So you will still be using this formula up here for constant variation. So constant variation and slope mean the exact same thing. Okay? So moving on to here, if we have the constant variation of 4 and slope is -4, does that make sense? Why?
Because you said they're supposed to be the same and one's a negative.
Oh, my bad.
Yep. So looking at that graph there, it gave us an equation, right? What is our constant variation? 4 over 1 or just 4, right? Because our slope is 4. So B. Okay. Okay, what about this one? What is our constant variation? -3. So what would our slope be? Our slope would be the same also, right?
Yeah.
So -3. All right. What would this graph look like? First, we have y equals 2x. What I want to talk about first, what is the difference of y equals 2x compared to y equals mx plus b?
There's no B.
There's no b or there's no y-intercept, right? So where would our y-intercept be if there isn't one? Where would our starting point be? Yeah, say it louder. Origin, okay? This is like y equals mx plus 0, okay? So that y-intercept would be 0 on that origin, okay? So one of our points would be 0, 0, the origin, okay? So looking at y equals 2x, first off, is that a positive or negative slope? It's positive, so which ones can we eliminate? The negative ones. D is negative. What's another negative one? A, because A and D are both slides. C and B are both up a mountain. Okay? So now we got to determine what our constant variation is, or our slope. So what is our constant variation? 2 over 1. Okay? So what's our rise? 2. 1, 2 over 1. So does everyone agree it's B?
Yeah.
What on C, they did the 2 as the rise. Okay? So they did the 2 as the run, but they needed the rise. Okay? So what we kind of just talked about, the equation for constant variation or direct variation is y equals kx. Is that any different from y equals mx? No. Okay? No matter what variable you use in algebra, they can all mean the same thing. Does that make sense? So if I could even put y equals cx. Same thing. Okay? Does that make sense? So, looking at the graph, what do you notice about those graphs? Okay, one's negative, one's positive. Our graphs have looked like this for the past week. What's the difference between, we already talked about it, this and this? Y-intercept is 0. So each graph of direct variation is going to go through what? The middle, or what? What's it called? The origin. Okay, each graph is going to go through the origin. Okay, so let's say you're working at Runza and you're trying to figure out how much you're going to get paid in a month. Okay, how do you get paid at Runza? By the hour. Okay, so if I had y equals kx, what would my k stand for? Money, how much I'm making, because what would my x stand for? My hours. Okay, so I'm going to put money times hours. Okay, well, if you work 0 hours, how much are you getting paid? 0. So if I make my XY table, if I'm getting paid or if I'm working 0 hours, I'm not going to get anything out of it. So we have to start somewhere, right? On our graph, we have to start at that median spot. Okay? So how much do you make it runs on an hour?
10.50. No,
10?
11.50.
Can I make it a even number?
Yeah.
Okay, 11. So, and if I work 12 hours.
11 is like that's not
132.
I mean no decimals. Sorry. What? You would get 132, so you'd go over 11, up 132. Okay, so we are going to have that constant variation when we make every hour. Does that make sense?
Yeah.
Okay, so if you don't do anything, you're not going to get anything, right? That's what this is saying. You're always going to start at that median place, that origin. Okay, that's the only difference between direct variation and slope-intercept form. Okay, now we're going to put some algebra in it. We have this equation, and we're given a y equals 9 and a x equals -3. And then we want to find the constant variation. So if we have y equals kx, and we want to find constant variation, which one's our constant variation? What letter?
Oh,
The k. Okay, so they said y equals 9, x equals -3. What do we do with those?
divide.
Okay, plug them in first. You're right. Plug them in. So y we said was 9. We're solving for k, and this is -3. Now what do you want to do? Divide. So you get k equals -3. Okay, so we're just using those two values to find the constant variation or slope. Okay? Any questions with this so far? Am I going too fast? All right, so suppose y varies directly as x and y equals 15 when y equals 5. Write a direct variation equation. What is our direct variation equation? Without the numbers, what is our general equation? What? Without the numbers. What is our direct variation equation? Y equals k times x, or kx. Okay, so now we just plug in what we know. What do we know?
Y is the 50.
Y equals 15, and do we know k?
No.
No, that's what we're looking for.
X is 5.
And x is 5. Okay, so we want to solve for k. How do we do that? Divide by 5.
3K.
So we get k equals 3. Now they want us to write it back into the equation. So what do we do? Now that we found our k, all we do, plug it into here. So we get y equals 3x. Because our k is now 3. So we have 3x. So we would get A as our answer. So we're finding the k and then making our direct variation equation from that. Okay? Go ahead and try that next one. That next slide. So you want to find x on this one. You don't have to write it back. Just find x. Sorry, find k. All right. We have y equals kx. How do we set this one up?
Plug in the Y.
Plug in the y and the x. So we have 15 equals k times 5. So what do we get for k?
3.
K equals 3. Okay, now it wants us to find the x when y is -45. What do you think we do once we find this k?
Maybe add x.
Plug it back into the equation.
Plug it back in with our new y. Okay, so we have our k and our y. So our y is -45 equals 3x, because we're trying to find that x. Does this make sense?
Yeah.
Okay. Now, yep, divide by 3. What is 45 divided by 3?
-15. Oh, yeah, it's just 15.
It's -15. Yep.
Well, I think it just said 45.
Oh, gotcha.
So that's all it says.
Gotcha. So we would get -15.
Yeah.
So once you find that k and it wants to find the other variable, just go plug it back in. Okay. Again, what does our k stand for?
Money.
Constant variation, or what have we been knowing it as? The slope. Yep. Here, I know you guys have dealt with this a little bit. Distance equals rate times time. So what does rate mean? Dealing with distance. How fast you're going, okay? And time is how long it's taking you, or how short it's taking you. Yep, to go that distance, okay? So rate would be what? So if it takes me 15 minutes to get to work every day, and the distance is 18 miles, what's my rate? And what's my rate going down the highway? How fast am I going down Highway 34?
You said it takes 15 minutes, and what else?
Think without the numbers.
How far away you were again?
What's the rate on Highway 34? 65 miles. What's the rate on the interstate? 75. Okay. What's the rate on a country road?
55.
55. 55. What's the rate in town? 25. Wow, you guys are good. Okay. So, distance equals rate times time. Let's look at this one here. So, distance equals rate times time. Okay, can you see how that looks similar to y equals kx? It's pretty similar, right? So, the rate is similar to the constant of variation. Okay, so if the distance is 26, so I'm going to plug in 26 for the distance. What's my rate? Do we know? We don't know the rate. What's the time? 3.25. So how do we solve for the rate? Divide 3.25. Someone help me out. What's 26 divided by 3.25? So we get 8. It wants us to write that as an equation. So what would my equation be?
26 equals 8 times 3.
Right, but now we want to put that back in with letters and variables. Okay, so I'm just plugging in that R for there.
T equals RH.
8 T or H for hours is what they use. So we would have this one here. Okay. A lot of us get confused when they throw different letters in. But really, does a letter change the meaning of anything?
No.
No, it's all the same. Questions? Okay.